Hey guys, today's problem is construct the minimum bitwise array 2. You are given an array called nums, which contains n prime numbers. Our task is to construct another array called ans, of the same length. For each index I, we need to find a value ans of I such that, when you take the bitwise OR of ans of I and ans of I plus 1, the result is exactly nums of I. In other words, ans of I and ans of I plus 1 must be equal to nums of I. There is one more important condition. You must choose the smallest possible value for ans of I that satisfies this condition. If it is not possible to find any value of ans of I that works, then you should set ans of I to -1. Finally, return the constructed ans array. Now let's understand this problem better using example 1. The input array is nums equals array of 2, 3, 5, 7, and the output we get is array of -1, 1, 4, 3. Let's go through each index one by one and see how this answer is formed. Index 0. At index 0, the value is nums of 0 is 2. We are trying to find the smallest value of ans of 0 such that ans of 0 or ans of 0 plus 1 equals 2. If we try different values, 0 or 1 is equal to 1. 1 or 2 is equal to 3. We never get 2. So, there is no possible value of ans of 0 that satisfies the condition. That's why we set ans of 0 equals -1. Index 1. At index 1, the value is nums of 1 is equal to 3. We now try to find the smallest ans of 1 such that ans of 1 or ans of 1 plus 1 equals 3. Let's try. 1 or 2 is equal to 3. This works, and since 1 is the smallest possible value, we set ans of 1 is equal to 1. Index 2. At index 2, the value is ans of 2 is equal to 5. We again look for the smallest ans of 2 such that ans of 2 or ans of 2 plus 1 equals 5. Try. 4 or 5 is equal to 5. This satisfies the condition, and it's the minimum valid value. So we set ans of 2 is equal to 4. Index 3. At index 3, the value is nums of 3 is equal to 7. We need ans of 3 or ans of 3 plus 1 equals 7. Let's try. 3 or 4 is equal to 7. This works, and it's the smallest possible value. So we set ans of 3 is equal to 3. After processing all elements, the final answer becomes array of -1143. This example clearly shows sometimes it's not possible, so we return -1. Otherwise, we always choose the minimum valid value. Now that we understand the example, in this solution, we start by creating an empty array called result, which will store our final answers. We then iterate through each number in the input array nums one by one. If the current number is 2, we directly append -1 to the result because there is no value x such that x or x plus 1 equals 2. For all other numbers, we use a bitwise trick to find the minimum valid value. First, we calculate the lowest set bit of current_number plus 1 using the expression current_number plus 1 and minus current_number plus 1. This gives us the smallest power of 2 that divides current_number plus 1. We then divide this value by 2 and subtract it from the original number to get the smallest possible value that satisfies the condition. For example, when the number is 3, this process gives us 1, for 5, it gives 4, and for 7, it gives 3. Each computed value is added to the result array. After processing all elements, we return the final array, which for the input array of 2, 3, 5, 7 becomes -1143. This approach ensures that the bitwise OR condition is satisfied while always choosing the minimum possible value. Now let's go ahead and run. As you can see on the screen, the output matches exactly what we expected. Since the output looks correct, let's submit the solution. And great news, the solution is accepted successfully. That's it for today's problem. If this explanation helped you understand bit manipulation a little better, make sure to like the video, share it with others, and subscribe to the channel for more LeetCode and coding interview problems. The problem link and full solution code are available in the description. Thanks for watching, and I'll see you in the next video. Happy coding!